Assalamualaikum everyone. So today we're going to discuss our new chapter, chapter 4, which is heat. Okay, so before I start, just to let you know, heat, this chapter is very popular in your SPM later or even in your final exam or next year, Form 5. Okay, so we have 4 subtopics. 4.1, thermal equilibrium. We're going to discuss this today. So thermal equilibrium are divided to two parts. Thermal equilibrium in daily life. So first thing, what is thermal? Thermal means haba lah. Equilibrium means keseimbangan. Then we're going to discuss how to calibrate, menentu ukurkan. Okay, let's say you find unscaled thermometer. So how to use it? Okay, so next class we're going to discuss 4.2, specific heat capacity, muatan haba tentu. So every substance they has their own heat capacity. So setiap benda dia ada muatan dia sendiri, limit dia untuk serap haba. Macam badan manusia lah. Kalau lebih sikit kita kena buang haba tu kan. Okay, so we do have calculation for this. Okay, how to calculate our specific heat and apply in daily life, in engineering, and also what happened to our natural life. Okay, then 4.3, we're going to discuss specific latent heat. Okay, haba pendam juga. Okay, tapi dia ada dua jenis lagi, lakur. Okay, specific heat fusion and vaporization. So dia cair and dia jadi wap. So we do have simple calculation again. Q equal to ml, quite similar to this one. And of course the application. So the last part is quite different compared to these three. Okay, this is about gas. Okay, something to do with heat juga. So we have three laws: Boyle's, Gay-Lussac, and also Charles' law. So each of these gas, they has their own conditions. Okay, when to use this, or when to use this part. Okay, so this one, hopefully we can discuss that by next week. So back for our lesson today, 4.1, thermal equilibrium. So make sure you have your textbook with you. Okay, so this is what happened in our daily life, so everyone knows. So let's say you have a metal spoon in a hot coffee. So what happened if you touch the spoon? So you will feel hot. Why? Because the heat from the coffee, okay, boiling coffee, will be transferred to the spoon. Okay, but after a certain time, let's say a few minutes, you touch the spoon again, then there is no heat over there. Okay, what happened? Disappeared? Okay, that is where we call equilibrium. Thermal equilibrium means the heat is transferred until certain part when there is no more heat transferred. Okay, so let's discuss this further. Okay, so let's see this part. Okay, we'll do the experiment later, hopefully. Okay. When two objects are in thermal contact, so this is important word. Okay, why I highlighted this part? The two object must be in contact. So mesti bersentuhan lah. Okay, kalau satu duduk bilik lain, satu duduk bilik lain, macam mana heat nak transfer? So must be in contact. The temperature of the hot object will drop while the temperature of the cold object will rise until temperature of both become the same. Okay, so heat is transferred from higher region to lower region. So from here to here. So ini pun ada juga tapi sikit sangat tak significant lah. Okay, so from higher region to lower region. Okay, then so you can see the process happens until, let's say, few minutes or few hours. Okay, depends on the object and how much heat transferred. So there is no more heat transfer. So dah kita kata heat transfer ni zero lah. So dah tak pergi lah. So bila zero, okay, kat situ barulah kita kata object is in thermal equilibrium, keseimbangan terma. net heat transfer between P and Q becomes 0. Becomes 0 ni means no more lah. Okay, let's say this is 100, oh sorry. Okay, let's say this is 100 Celsius and this is 20 Celsius. So heat is transferred during the process. Ini mungkin dah kurang sikit, dah jadi 80. Ini mungkin dah jadi 40. Okay, until lastly both has the same temperature. Let's say both has 60. So means you cannot flow anymore. You cannot receive anymore. So there is the condition where no heat transfer means becomes 0. So this is where we say it is in thermal equilibrium. Okay, bahasa mudah, senang lagi saya bagi satu situasi. Okay, let's say when you touch an ice cube. Okay, katalah ni jari awak. Okay, jari gemuk sikit. Okay, suhu badan kita let's say 36 Celsius. Then this is an ice cube. Okay, ice cube, let's say 0 Celsius. So when you kat sini tak ada apa lah, nothing happen because no thermal contact. So you have to touch. So awak pergi pegang. So bila awak pegang, kenapa rasa sejuk? Dah pegang ais, cikgu sejuk lah. Okay, you rasa sejuk. Why? Because your heat from your body is transferred to the ice. So heat keluar, jadi sejuk lah, dah heat dah keluar. So tangan kita jadi sejuk lah. Yang ni pula duk tak duk, kenapa dia tiba-tiba cair? Sebab dia terima heat daripada awak. Sebab tu ais jadi cair. Tadi dia duduk dalam elok lah. Okay, then until certain condition, kalau awak pegang lama sampai kebas 6, so you dah tak rasa sangat dah sejuk tu. Alah, dah biasa lah. Kenapa? Because your fingers and the ice cube achieve thermal equilibrium. So dah tak ada lagi heat keluar. Dah tak rasa sejuk lah. Okay, dah kebas dah tangan. So that's the situation. So make sure in your explanation later, mesti ada perkataan ni, thermal contact, ada perkataan no more heat transfer from higher region to lower region, dan ada perkataan thermal equilibrium is achieved. Time ni lah. Okay, then in our daily life, okay, thermal equilibrium in our daily life, okay, this one I think no problem with that, boleh baca je. Okay, we can use both, okay, to heat or to cool down. Okay, thermal equilibrium cause two objects in thermal contact to reach same temperature. Okay, these are the example. So why we put the batter in the oven? Okay, so kenapa selalu kita kata panaskan oven dulu ke? So why? So the hot temperature inside here will bake, okay, your cake or anything you masak. So until it reach the same temperature. So same goes to the fruits or anything you put in the fridge. Okay, so you put in the fridge. So what happen? Asal ni tak sejuk, dah masuk dalam fridge. So haba dia akan dikeluarkan until certain point, certain time, no more heat is transferred to the refrigerator. Then they achieve thermal equilibrium. Okay, so this is another one. Our clinical thermometer. So thermometer asal sebelum kita guna tu, dia punya suhu sama dengan suhu persekitaran lah, let's say 27 Celsius. So when you put inside your mouth, so your heat from your body is transferred, okay, to the mercury inside there. So the mercury will expand sampai bila dia nak stop? Sampai no more heat transfer. Kenapa tak stop kat sini? Kenapa dia mesti stop kat sini? Kenapa tak pergi lagi, tak pergi lagi? Okay, because no more heat transferred means you already achieved the thermal equilibrium. Okay, so that situation. Okay, so the rest can baca. Alright, the last part is called how to calibrate. Okay, to calibrate a liquid gas thermometer using two fixed point. Okay, what is meant by to calibrate? Calibrate ni kita perbetulkan lah, menentuk ukur. Okay, kita betulkan. So please read this part 123 and 124 the pages. Okay, the situation is like this. Okay, let's say you pergi korek mak-mak kita yang canggih tu, you ada jumpa satu thermometer, tapi dia punya skala dia hilang. Ada gelas di chain ni, tak ada ni. Skala kat sini semua tak ada, hilang. Okay, Dah luput habis lah, hilang lah sebab lama sangat kan. So, how to use this? Kita masih lagi nak guna benda ni, dia tak bocor apa pun, cuma dia punya label dia semua dah hilang lah. So, what should you do? Okay, first thing, you masukkan dalam ais. Because we know the ice is at 0 Celsius. So, let's say 0 Celsius dia kat sini. Okay, that's 0 Celsius. Then what happen? The same thermometer, you put in boiling water. You put in boiling water, so we know water boils at 100 Celsius. So, kita tengok sampai kat sini 100, so mark this part. So, this is 100. This is 0. So, now you measure this, the length. Okay, ini kita panggil L100. So, you measure the length. Okay, dia tak payah buat lah, 1 sampai berapa ni kan. Kita buat scale je. Then, you jumpa lah satu mangkuk mana. Tahu jumpa, ada liquid dalam ni. Tak menggelegak ke sikit ke apa. So, you want to know, what is the temperature of this one? Okay, so, what happened? Ambil dia yang dah kita mark. So, buh lah kat sini. Buh kat sini, tengok dia naik sampai berapa. Okay, dia naik sampai berapa kat sini. You ambil this ukuran SL theta. Theta is the unknown. So, let's say dia naik sampai sini. So, this is our L theta. So, from here, we can do the calibration. We can do simple calculation by using this equation. So, how to get this equation pun, tak payah tahulah. Senang je. Okay, buat perkadaran je. So, theta equal to L yang kita nak ukur bahagi dengan L100 times 100. So, let's say over here is, you measure the length here, the unknown liquid. Let's say this is, okay, let's say this one is 20 cm. So, dekat sini 20 cm. Then, over here is, let's say you get 4.5. So, 4.5. So, 4.5 divided by 20 times 100. So, that is the answer. Okay, the unknown liquid. So, we still can use the thermometer even we don't know the scales. So, we can determine, calibrate the scale. That's the word. Okay, so we can see this one example. Aisha uses an uncalibrated laboratory thermometer to determine the temperature of the liquid. She finds that the length of the liquid column when the thermometer is put in the liquid is as shown in the figure. Calculate the temperature of the liquid. So, we have 0 until 100 is 12 cm. So, that is your L100. So, the unknown liquid is 4 cm. So, that is the unknown liquid 4 cm. So, times 100. So, you get the answer. So, means this is 4 over 12 times 100. So, 1 over 3. So, we get the answer around 33.34. Okay, that is the answer. So, you can try this part. See you again on 4.2 next week, inshallah. Okay, thank you.